Well, good morning, and thank you very much for the kind introduction. I would also like to thank Formas and the organizers for inviting me to give this short presentation. And let me also say that it's really nice to be back at Formas and in Stockholm, even though it's virtual. I guess it's the beginning of our digital future in many ways. I have few slides with which I would like to illustrate my presentation, so I will share the screen. Let me just start this presentation with a cartoon, and I hope you'll see it in a few seconds. Basically, I think what it shows is that the COVID-19, as we all know, is a major and immediate threat to humanity. But we should not forget other challenges at the same time: climate crisis, injustice, inequality, and never increasing pressure on the Earth and the Earth systems. So in other words, this is why we really need a systemic and systems analysis and scientific assessments to understand this complexity and provide useful advice to the policy, but I would also say to the society. So that's the major goal. But let me start with the history of IIASA, and I would say that's the history of systems analysis, also because Formas is a Swedish member of IIASA. The beginning of the institute goes back to 1967 summit in Glassboro of Premier Kosygin of Soviet Union and President Johnson of US. Their idea was to organize an East-West institute that would deal with the major challenges of the societies, like energy, oceans, environment, and health. I put that in red and amplified it. So I would argue that this was quite visionary, if you think about it. It's almost more than 50 years ago. And in many ways, it could have been said now. And below in the picture, you see Howard Reifa, the first director, and Vigiani, the first chair of the IIASA Council, governing body, where Ingrid represents Sweden. Let me just say that in Howard's memoirs, he explained how the name came. The East-West was too mundane, so they decided to call it Applied Systems Analysis. And Howard said that suggestion came to call it systems analysis because that would give the opportunity on working whatever is scientifically exciting. And then they added apply to make it even more vague what the Institute could work on to tackle the challenges. So this is the beginning, and from the beginning, integrated and systems science played an important role from my point of view. Climate issues, CO2 in 78, energy, the first global energy studies, very famous sustainability assessment on agriculture, for example, as well. And IIASA participated strongly already then in the scope activities, for example, together with Bert Bolin, but many of you might remember Bodus from the beginning. So in some sense, IIASA was one of the key institutes in working on these systemic challenges of the Earth. And I would want to mention the Human Environment Conference in 72 in Stockholm. So that was in many ways the beginning of the Earth Summit and this kind of global thinking, how to reach the major challenges of the humanity. And I think that's the first Earth Summit, really, and the beginning, almost 50 years ago. Next year will be a 50 years anniversary. So that's just a few words about the history of IIASA. I would argue that the world is in many ways at the crossroads today, even after almost 50 years of systemic thinking and science for understanding better the systems. And the reason why I'm saying that is that we, since the beginning of Industrial Revolution, we had really explosive development in the world. And as a consequence, we are transgressing planetary boundaries. We are threatening the critical functioning of the Earth systems on which we dearly depend. At the same time, we have left billions behind. And so just some illustrative numbers. Global economy increased 100-fold, energy 50 times in these 200 years, and carbon dioxide emissions 30 times. And the adverse impacts are that the temperature has increased well over 1 degree in the meantime. But also I would like to highlight that 9 million people die every year prematurely from indoor and regional air pollution. That has a lot to do with the 3 billion people who do not have access to clean cooking fuels. And of course, quite a lot that we depend on the fossil energy for almost all of our activities. So from that point of view, my argument would be that 2030 agenda with its 17 sustainable development goals and the Paris Agreement are the only way forward. I personally don't even think that there is a plan B. And the advantages that would bring many co-benefits for the people and the planet if we can achieve to be on this kind of more sustainable development pathway. And for that, we need systems analysis. Let me just illustrate that there is a great movement in this area, and I'm sure you're all familiar with it. This is a new scenario of how a European Commission might move forward on greenhouse gas emissions and economic development, shown in percentage growth. And you can see this will require Herculean effort. Basically 55, as you know, 55% reduction in greenhouse emissions in this decade, and then going toward net zero by the middle of the century. There, as you can see, still some positive emissions in critical sectors, but they would be offset by negative emissions. That's the basic idea. And that is consistent with an article we published in Science 2 years ago with Johan Rockström, John Schellenhuber, and others, where we asked for the necessity of having a carbon law, namely halving global emissions every decade. And I think this is inherent part of the European Green Deal. So I think we have a really huge way forward. Now, one can question the idea that economic output would double in this period. But of course, it depends what's growing. If it's not the consumption, then perhaps this is not a bad idea, because even in Europe, many people are left behind. So I think the European Green Deal can be seen as an action agenda for achieving the 17 Sustainable Development Goals of UN. Ingrid has shown them. I'm showing a slightly different picture here. As you can see, it's a little bit unorderly. It comes from a meeting we had in Copenhagen 2 years ago that UNDESA organized. And the reason why I like it is that it illustrates that they're all somehow connected. If you look at 13 and 7 in the foreground, climate and energy, they're essentially inseparable. But that's true for health, it's true for food, it's true for urbanization. So it's a holistic agenda and very aspirational agenda. Not that much time is left, unfortunately, only another decade, 5 years have passed. But I would argue systems analysis is absolutely necessary to understand better how this implementation should occur. And I think we have to work really hard on the science for achieving the SDGs. That is happening. One of the activities that we have been involved is the initiative called The World in 2050. I'll say a few words about that, how to achieve the 2030 agenda, but also JRC, for example, the Joint Research Center in Europe, and many other organizations are working on it. And I think we all come to the conclusion that from a systemic point of view, we need to maximize the synergies among the SDGs and minimize the trade-offs, and if possible, avoid the barriers. And I think that's really well illustrated here in the work of JRC based on the literature. In the outer ring, you see the 17 goals. In the inner ring, some of the 169 targets and their relationships. Now, the point I would like to make is it's a real mess. I've been working on this now for many years, and I would have to admit, I cannot internalize all of these relationships. The complexity is huge. And this is why I welcome very much in implementations like the European Green Deal that simplifies this and hopefully simplifies it based on solid science and solid scientific advice to policy and the society. And that's exactly what we wanted to do in the World in 2050. And you see the website on top where you can download the reports if you're interested. What we have through the analysis, what we have achieved through the analysis is to simplify the 169 targets and 17 goals to 6 transformations. And I will not read them all, but we argue in the report based on integrated modeling and the analysis that if we can achieve those integrated 6 transformations, we would be on the best way of achieving the 2030 agenda and also the Paris Agreement. And the digital revolution is perhaps one of the keys, and in the next few minutes before I conclude, I would also like to talk a little bit about that. But before that, let me just show you this kind of simplification of the agenda. I think is really important to reduce the complexity. So on the left, you see the 6 transformations that I presented before from the world in 2050. We published that also in sustainability, in Nature Sustainability in 2019. In the middle, you see the 6 entry points to transformations that the Science for Sustainable Development report for the UN has published, and the congruence is huge. They're more or less identical agendas. So there is some convergence in the science. And on the right are the 8 priority areas of the European Green Deal, also very similar, energy systems, food, and so on, climate. But, I don't want to argue whether one should have 8 or 6 or 7. It's important to have a smaller number that can be translated into roadmaps and the policies and the way forward. So I think this simplification is really required. Now, what I would like to also share with you is from our last report. We looked at the issues of decent living and sufficiency. And maybe this is one way of presenting it. On the horizontal scale, you have human well-being. In the vertical scale, services provided like food, energy, and so on, good governance. And very often the discussion in terms of the way forward is about basic needs. We believe that that is not appropriate because basic needs is the minimum. It is not inclusive. What we have been arguing, and we have provided analysis for it, that based also on the literature, that we have to achieve decent living for all. But this is not sufficient. What we also need to do is avoid overconsumption. So it's about too little and too much. And this is what we call the sufficiency corridor. And it is clear, in my view, that cannot be achieved only through technological and economic measures. We need new governance for the sustainability transformation, but I would also argue strongly new values, norms, morality, and perhaps also new ethics. So that's the main point. And digitalization is there a huge opportunity and a threat. And with that, I would like to conclude. And I'm not only referring, or rather, we did not only refer to artificial intelligence in the report, but rather to convergence of many digital technologies that are emerging right now. So the metaphor would be like the emergence of the first industrial revolution through steam, steel, iron, locomotives, railways, telegraphs, and so on. And a good example is here in the middle, is the digitalization through mobile telecommunications. In the middle, you see some analog devices that perhaps some of you still have at home for communication. They would require about 500 watts of energy. They're replaced by a single smartphone that requires 100 of the energy. This is a huge potential. But not only 100 of the energy, it also requires 25 times less embodied energy and materials. So it would be also material sparing. And I think this is an indication of possibilities of the digital revolution in the context of sustainable development to improve the efficiency and achieve the sufficiency that I talked about. And by the way, everybody in the world has a mobile phone. This is a huge achievement, even the billion people who do not have access to electricity. Here are 2 examples of some of the technologies. Augmented reality, I would say, also artificial reality, as long as it's not fake reality, is a huge opportunity. The technology that I really like a lot is the Da Vinci robot that with 5G and internet allows operations, high precision operations anywhere in the world. Operators don't even need to be there. So the opportunities are huge. But there are also threats. And this is the last thing I wanted to share with you. think just about artificial intelligence together with other digital technologies. In the short term, there are huge concerns. We already have structural unemployment worries, and COVID-19 has amplified that. I would argue the best and the worst in our societies. And it's probably true that transformation towards sustainability will open new jobs, but that doesn't mean that the people who are unemployed now will find a job. So we need social safety nets like in Sweden throughout the world. The other question, and very scary, is proliferation of autonomous weapons. And the question one could ask is, what would be the legal status of autonomous systems? Think about self-driving cars. There are lots of legal challenges. But in the long run, one could also ask the question, what would be our status in the world full of artificial agents that might be like the mobile phone and internet, also changing our behaviors? And then last but not least, what I like to mention is that was Alan Turing, or the question he asked already 70 years ago, whether consciousness in artificial intelligence is possible at all. So you can see challenges are huge, but as well as the opportunities, and these are the 3 reports, if you are interested in downloading them. So I would like to stop here and allow time for some questions if there are any. And if I'm sure that there are ambiguities in my presentation, so please do not hesitate to send me an email below and I'll try to answer to the best capacity I can. So thank you very much for your attention, and I'll now stop sharing the screen.
Thank you so much, Naki, for that insight and perspective. I think it's a very good foundation for the further discussions today. I have one question for you. If you would pass one issue, one question, one challenge on to the discussions later on here today, what would that be? Something that you find to be most relevant to discuss?
Yeah, that's a tough question, as none of us really know what the future will bring. It's unpredictable. And I guess that's why we have scenarios and the analysis. So the first part of my answer would be, and I'll try to be brief, even after 50 years of systems analysis and scenarios and future research, I still think the science is not there where it needs to be. I think that we need a transformational science, but to transform the science for these challenges, but we also need the science for the transformation processes. So I think that's a big challenge in the systems analysis and integrated analysis. Then I would argue that it has to become even more policy relevant, and that's why I put emphasis on simplifying the agenda and perhaps trying to speak with one major voice for science. That means assessments would be required, not to transfer too many contradictions, even though we have to reflect the uncertainty. I think that would allow for better strategies and roadmaps on the way forward in fulfilling the European Green Agenda. And I think that needs to be the highest priority. And then last but not least, what I said toward the end, I think we need new values and behavior. This is not going to happen just, I think, through the political measures and through the policy. I think it has to happen from us as people, as a population. So science has to be socially relevant. And I would argue inclusiveness there, we need also to understand a little bit better. Inclusiveness, Sweden is probably a good example in that direction, but we have to make sure we don't leave anybody behind. Otherwise, the transformation will not work, in my view.
Okay, I think there is time if anyone has another short question for Naki. We have time for that. Anyone? Anders Nordström.
Just one question. We're living in a world today with sectors, and you're talking about systems. What's your reflection in terms of how to move from a way of managing our world by sectors to managing it by systems? What will it take to make that transformation?
Yeah, that's a tough question, and I would add to the question also that we focus also at the local. So I think that the challenge is to integrate local with global, bottom up and top down, as well as to integrate the sectors. And this is why I emphasized, in the short time, I try to emphasize let me call it the end use. you know, the human behavior, human consumption patterns. It is from our demand that will also structure the sectors. But we clearly need many, many more integrated policies. Let me just conclude this attempted result with one statement. You know, in the old days, agriculture was, for example, vertically integrated. A farmer would produce, would bring to the market, sell, store, you know, make the products and so on. And today it's across, food is across all sectors. It's not just in agriculture. Agriculture is a tiny part of our economy, yet the food is a really big part of our economy. So the point is that I think by going into sectorial view, we have fragmented our policies, we have even fragmented our research. So this is why I think the horizontal is one of the highest priorities.
Okay, thank you. I wish we had more time for more questions, but we have quite a tight schedule today. So thank you very much, Naki, for being with us today. You're most welcome to stick around and listen, but most of it will be in Swedish. So I don't know, but you are most welcome to stay if you want to. Thank you.
Thank you very much for listening to me. I'll stay for a few minutes and then I will leave you. But questions if you have any. Thank you.
Okay. Thank you.